Hello, how's it going? How's everybody doing today? What's up? It's Thursday, July 31st, 2025. Welcome, welcome, welcome. Um let's just give me one sec. Let me just open up the chat here. How do I do that on here? I forget how to do that. Oh, you know what I need to do? This is what I need to do. We need to go live chat. And then I do that. There we go. Now I got my chat. Got the chat up. I see Ed's here. What's up? How's it going? Hope everybody's doing good. Bright and early. Yeah, not much. Not much. Yeah, I was my wife is she's gone for the week on business. So I'm solo parenting this week. Uh yeah, the one of my youngest uh daughter had a was under the weather, so she was home from daycare earlier this week, and my oldest is on her tablet watching YouTube videos while I do this live stream, and then afterwards we're gonna go maybe out for a little treat, maybe grab a little ice cream or something. It's summer vacation for her, so yeah. Anyway, I hope everybody's week is going well. Uh, what happened this week? Well, so far, what's happening? Brian, what's up? Thanks for coming. Glad you could make it. Um, yeah, what else? Got the sampler done. Sampler's done, right? Everybody saw the video, the posts. It looks kind of cool. Turned out okay. I'm happy with it. Um, Ed, I should tell you that I didn't get the soft touch buttons that you had suggested, but I got ones that are like really low profile, and the distance from the actuator to the conductive material that presses it is a lot smaller. So they're really quiet and they're really fast. So thought you just might be interested in that because we were talking about push buttons before. Probably should have mentioned that in the video. Um, but yeah, I didn't. I should have. There's a lot of things I should have done with that video. But, you know, um, yeah, I'm happy with how it turned out, though. I'm happy with how it turned out. Um, I do have to fix. I was talking to, or I had mentioned to, I mentioned to Brian um, about the MIDI through circuit. Um, that it needs a little bit of help. So I might do that in a live stream after we're kind of done our pre-planning here for the SP1200, or at least once we're kind of figuring things out, I might use a live stream and fix that MIDI through. I'm fairly certain I know what's wrong, and it was a fault on my part. Um, but yeah, I like how it turned out. I like how it turned out. I think um, yeah, for the first project, having it like a raw PCB is kind of cool. And I still have four more PCBs that aren't even populated. So I was thinking that maybe I'll, I was going to give them away, But the I don't feel good about giving them away with the MIDI through issue because I don't want I don't want people to get angry with me, and I don't want to break somebody's stuff, you know. But if I figure out an elegant way to, if I find an elegant way to fix it, maybe I'll give them away, you know, or like maybe I'll just build the MIDI part of the circuit and then send out boards like that. I don't know, or I could just keep them for myself and have four more identical samplers, you know. I think that might be kind of neat too. Yeah, exactly, exactly. Yeah, maybe. Um, yeah, I don't know if anything would happen. That's an interesting point, though. You know, it actually could be an interesting experiment, maybe having ones that were operating at different bit rates, um, like go even further down. Because right now, I think, what am I sampling at? 8-bit? I wonder if I can go further down than that, or trying um, a lower sample rate too. Because I did have on the final version of this, it's actually operating at 44.1, which is significantly higher, obviously, than the original SK1. But this DAC, even in that mode where I was um, doing that, what do you call it? The that the I can't even think. The SPI um, audio output, or was it I squared S audio output or whatever? I can't remember what I did now, but yeah, um, didn't sound that great at 90 or 9.76. So, but it was like super distorted, and I wanted it to sound a little closer to the SK1, right? So I upped the sample rate, and it kind of helped out a bit. But yeah, I'm happy. I'm happy. I'm very happy with how it turned out, despite the uh, the MIDI through problem. But as I said, it's a simple fix, um, and I would like to get the MIDI through working because then I could populate these and use them all together, right? Which would be kind of cool. But anyway, so it's nice to be like basically done that project. Feels good. It really does. Feels really nice to be finally moving on from that. Um, just because it was taking a long time and you know, I think even as I was building it, I was kind of realizing that more features were going to be needed. So that was sort of the, you know, so yeah, so it's nice to be finished because I know that the SP1200 sampler is going to be closer to the kind of thing that is going to be useful for like actually making music, right? Um, Before we jump into the SP1200, I just wanted to give a little update about the other side of the basement. Um, yeah, it's coming along. I installed some, I think I mentioned last live stream that I installed some shelves, but it wasn't really enough for one video. And then this past weekend, I went and saw my dad, and he's going to give me more cabinetry with like a countertop and everything, like 9 feet, 9 feet long. So that will be really cool to have that set up down there, and hopefully I'll be able to set up a spot where I'll be able to do all the overhead kind of stuff and set up all my soldering stuff and my my bench power supply and my whatever else, my reflow stuff, which is sitting around here somewhere, and all that kind of stuff. So yeah, I don't know if I'm going to post another video this week, but yeah, for that, because I don't think he's going to be able to deliver it till next week. So yeah, a lot of space, a lot of space. So it's really good. And I think what I'm gonna do eventually too is obviously all this stuff is gonna be on the other side of the basement as well. So I think I'd like to have the roll top desk over there at some point, and then obviously all the components and stuff will be over there. So yeah, and I'm actually working on another. I've got like a desktop machine that was given to me um, by my mother-in-law. Uh, that I'm gonna have like Windows, just a Windows machine there to run my CNC that I'll have over there, and what else? And my and run like flat cam and stuff, so I can set up my CNC jobs. So yeah, so it's coming along. It's just there's really not enough for like a video yet. Um, but so it might not there might not be another video for that this week again. It might have to wait till the following week, which I think is okay. I mean, I know that it's not sort of like, the video series that people are really drawn to anyway. So, but anyways, so I did have time this week to work on just a little bit of the SP1200 stuff. And Brian sent over an awesome idea um, to, um, what's the word, to achieve the goal that we're trying to achieve. Let me just pull up that document. It's not there. This is what we're looking for. Okay, let me just move myself out of the way here, and we can take a look at the pre-build document, and we can talk about stuff. So this is what we had last time. So this was kind of the notes that I was making, you know, um, during the last live stream, kind of near the end when we were chatting about stuff. So all these inputs, right? Our screen, our rotary encoder, shortcut buttons and stuff, yada yada yada. Anyways, this is basically the specs that we're trying to get, right? Which I think is it's pretty ambitious, but I think we can do it. Um, and then we have our recording specs, um, which is 12-bit, and I think it's actually 10.2 seconds of memory. And I mean, like that's something that we can increase if we want. Um, you know, I think that'll be an issue down the road anyway. Um, yeah. And then we have Brian's idea, which was really cool. I really liked Brian's idea. So he's got a master main controller, and then he's got a total of three like slave modules. Um, so the idea is that he has one microcontroller, sort of like handling all the big picture stuff, right? And then a total of three voice modules. I think it was three, right? And I believe right, three. Um, so okay, so we have one that handles its own. So we still have a total of 8 channels. So it'd be 8 channels. The main microcontroller would have its own sort of like 2 channel output, and then three other ones to handle the other eight. Um, the other six, sorry, the other six outputs. So I think that, I mean, that's a pretty cool layout. and I dig it. Um, I think it makes like um, looking at the schematic of the main of the SP1200 is that that's kind of what they're doing too, right? I mean, they don't really have voice modules, but they have uh, sort of like different modules of the of the microcontroller um, that handle specific tasks, right? So it'd be the same kind of approach here. Um, what's the PCM 5102 worth? Let's just do a quick digikey. So we got a little breakout board here. I'm assuming this is what you were using, eh, Brian? Something like this? These little breakout boards? Super cheap. That's great. Oh, here we go. 495. Line level output. Right. We got stereo output. Yeah, yeah. It's very cheap. And I mean, the specs look really good on it, right? Um, so that's really cool. I really like that a lot. Um, uh, I guess the thing is like, yeah, it does. It does look nifty. It does look nifty. They've got, I wonder what the different, there's a 5100 for $1 less. I don't know what the difference is. Probably just some specs, some simple specs. Um, oh, it's like a slightly different signal to noise ratio kind of thing. But it looks like it's the same sort of thing. Um, so that's pretty interesting. And like it's got a huge range for sampling frequency. And yeah, it's it's definitely a solid choice. Um, so it's kind of cool. I like this little module. It's really cool. There's okay, right. Well, one of the things that I was looking at was I was back in the schematic earlier, and let's just take a quick look because I was trying to figure out something. Oh, you know what else too? I was watching actually before we do that, I wanted to mention something that was pretty interesting. Um, these I was looking up. I was looking up like you know what? Actually, sorry. We'll come back to these outputs in a minute. Let's go back to the DAC while I'm thinking about it. Right, right. Um, so one of the things that I was looking at was I was looking at this sort of circuit here, and I realized what they were doing, and I didn't even it didn't even dawn on me what they were, what was going on. And yeah, because I was like, how are they getting one, how are they using one uh, um, digital to audio converter It's got one output, right? How are they how are they getting that single output to go 8 times, right? And like out 8 channels. And then I realized what they're doing is they're doing time division multiplexing, right? So they have a sample and hold circuit in here that's storing all that's basically taking that data, okay? It's going from the DAC out and we're going into this multiplexer here, this analog multiplexer. It's taking the signal, dividing it amongst 8 times, and using these capacitors to store that analog voltage for each of the steps, or for each of the bits, sorry, and then chucking them out the outputs. So that had me thinking, I was like, maybe we could do something like that and cut down on the amount of um, DACs that we'd need. Um, so that's something that I need to dig into a little bit more, because if we could get away with using one module and being able, as long as it has 12 inputs, right? Or yeah, 12 inputs, right? Yes, 12 inputs. As long as it has 12 inputs, we can take those inputs and go down to one channel and then divide them up on the other side. So we don't need those specific outputs. Um, we don't need like 12 outs kind of thing. You know what I mean? Um, and the other thing with this sort of setup is then we'd have to have one sort of like dedicated ESP32 to handling just the audio, just the processing of the audio, which might be more efficient. I don't know. I don't know. Have to think about that. But yeah, it's really neat. It's really neat how they do it, and it's like, because I was looking at this and I'm just like, how are they pulling this off? And then it dawned on me that it's a sample and hold circuit. So you get your sample and hold, right? It's taking all those voltages over time, and then these capacitors, yeah. And then this ADC here, this 8-bit one, is basically um what's the word I'm looking for? It's like sending information. It's like sending the volume information, or um not the volume, and well, yeah, volume, or any other sort of like digital parameter that's affecting that'll be applied to the output, um, coming out of each channel. Um, it would involve more building. We'd probably have to go through and build some of this stuff on an actual breadboard to verify that these values would work for us. And it would also require a little bit larger of a little bit beefier of a power source for this project. That's the biggest, that's, as I see it, that's sort of like the one thing about this approach that kind of sucks is that you know we're going to be using like plus or minus 12 or plus or minus 15 in conjunction with a 5 volt or 3.3 volt supply, um, to power the op amp stuff. Um, so yeah, we're getting there. We're getting there. I'm gonna take a look at that module that Brian's been suggesting and see what we can do. Um, in terms of using that module, because it's so cheap and it's low power, and maybe it just means like we have to hack the board a little bit. Um, But it would be really cool if we could do something similar to this, where we could get those 8 outputs out of that single chip. You know what I mean? I think that might be really interesting. Um, and then the nice thing is that uh, it's I squared. Is it I squared S? Is that what that one is? I squared S, I believe. Yeah, I squared S. So it's like communication on it is a lot easier, right? Or at least a lot more documentation out there probably, um, for us to be able to use it, right? Because as I said in the other live stream, is I don't love the idea of um, using these sort of like legacy parts because I really get because they're, $30 or whatever. It's like it's out of the like I just would feel very responsible if somebody spent $26 on a chip like this and then blew it, or or whatever, just like fried it by accident. I would feel pretty bad about it. So these Adafruit modules are like, it's, a lot easier to hook up, a lot easier to work with. So that's kind of where I'm leaning towards. But yeah, I'd like to see if we can figure out a way to do this kind of like sample and hold approach with this chip, or with this module kind of thing. I think that would be pretty cool. Um, I do think we are going to need multiple microcontrollers for sure. But if we can cut down on the amount of sort of like quote unquote voice modules, um, like Brian suggested, I think that would probably be pretty smart. If we can do it. I don't know. As I said, I'm gonna have to kind of like dig in and see what we can do. I didn't have a ton of time this week to really dig into it, so I'll definitely make some time uh, soon to really kind of like try to figure that part out of it. And then I wanted to mention something about the outputs that I found really kind of neat. So, in terms of these outputs, right? It's interesting. Um, so they're actually okay. How am I going to describe this? So the first, so there's 8 outputs, right? We got, I mean, according to the schematic, it's channels 0 through 7, right? Um, and 6 and 7 are just literally just like a buffered output, right? So it's taking the signal from the multiplexer, right? It's got our capacitor here that has the stored voltage, right? And then it just chucks it through a op amp buffer and then out, right? So you get just the pure audio coming out of it, right? It's like from the ADC out, right? And then that's for channels 6 and 7. And then 5 and 4, I should say this, 6 and 7, or 7 and 8 in sort of like the terminology of the back panel. That sounds good. What I did send you earlier, Dave, I saw the guys basically are using an Arduino Nano, although he doesn't really go into it, if anything has him in the way. His first project did have 8 voices polyphony, though. Yeah, yeah. Yes, this analog multiplexer. Yeah, yeah. There is this guy here, right? Um, so, where was I? So then these other outputs, they have all these filters on them. So these are so channels 5, 4, 3, and 2 all have a filter on them. So you put the cable in and you just have the tip getting to this first point here and you have just the regular output, right? You just have like a just a buffered signal just like 6 and 7, but then you press it in all the way and you get this filtered output, which is kind of neat. And with channels 1 and 0, they don't have these sort of like basic sort of, op amp style filters on them. They have the buffered output at the where the ring would be, like the first section, right? Then they have these like crazy dynamic filters uh, applied to them, which is really interesting. So you can get a buffered output on every single one of these channels, or you can get a filtered output, which is pretty neat. It's pretty neat. I didn't realize that's how it actually worked. Um, that's because I've never actually used an SP1200 before, so I thought that was kind of neat. Um, I don't know if we need to go to all that trouble, um, doing those kinds of features because um, I don't know. My thought is that if you have a monophonic output, that's just sort of the buffered signal coming from the DAC through the analog multiplexer, you know, you have an individual output. It's like if you want to run it through a filter, you can just take a monophonic output and run it through a filter. That, like some sort of like external mixer or whatever. I don't know. Um, if people are interested in having that option, I would be definitely down for, sort of like recreating these circuits. Um, I don't know though. I don't know if that's what people are interested in. I know this chip here, this guy, is not available anymore, or at least not available. Like availability is not great. You can get things that are similar, um, but yeah, yeah. I don't know if people are into this kind of thing, or if it's just sort of like let's just get the outputs and then we can do what we want with like a monophonic signal. Um, yeah, but yeah, it's pretty neat. It's pretty cool. And then all they do is they just, if you look here, so these first, I guess where the ring would be, where you get your buffered signal. Yeah, no, it sounded great. It sounded good, Brian. It sounded really good in the video. So yeah, I think it's kind of neat how they did this. Um, but yeah, um, so yeah, I think we need to do a little more digging on that module. Um, like I wonder if they have a data sheet here. See if they have a data sheet. Just kind of curious of the. I think there was a data sheet. Oh, here we go. Okay. All right. Let's just try and get a little bigger here. Okay. So 2 volts RMS direct path. So you have like a, I guess it's part of a series, right? And we're looking at the one with 112, I believe, right? 112 dB, that guy. No DC blocking capacitors required. Okay, cool. And then you have a line output, left and right line output. So, okay. Hmm. There must be some kind of um, see if there's anything. Applications requiring 2 volts RMS audio output. So there must be some sort of like internal circuitry that does like sort of like the gain on it. Let's see here. Okay. And then actually before I do that, what's the supply voltage? Oh, so it's like really low voltage too. That's nice. 3.3 would work, which is nice. Uh, System clock detection. Common audio sampling frequencies 8, 16, 32, blah, 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 blah. But you had it working with 26. Okay. I think I'm going to order one of those modules, um, those Adafruit modules, and start playing around with it. And everybody's cool with sticking with the S3 because I'll order some of those too. Kind of curious to see if we can get this to work the way that I think we can get it to work. Provides the piece provides two types of interpolation filter. All right, I believe you. Yeah, I mean, it's a data sheet, a lot of dorky shit, a lot of detail that we probably don't need. Although I'll probably eat my words saying that. So yeah, I think this is like probably the way that we need to go. Um, yeah, just for the sake of simplicity and just sort of like, I don't know. It just feels like, yeah, I feel like it's just like yeah, I'm just like I said, I'm nervous of people buying like sort of like those more vintagey or just, a little bit more sensitive kind of like stuff, right? Like the sensitive ICs and stuff, and spending $30 on it and it blowing up on them. Well, they have recommended output filter. Okay. I mean, this seems like it could be like I don't know what would be unless I'd have to yeah, I got to read some more. I got to dig out my dig through some of my books to figure out whether what I'm thinking would work. Because what we want to do is we want to take this output here. We want to take this output right here, right? And figure out a way to divide it up 4 times each, right? Yeah, I noticed a difference for sure in the quality. I did. Um, I thought it was. I would have been cool to hear some like pitch. Uh, was there a pitch variation in there? I can't remember. I thought there wasn't, but it sounded good to me. I think when you drop the pitch, you'll get that artifacting that is sort of like sought after, right? With the with the SP 1200. And yeah, Ed sent me before the live stream. Ed sent me this that everybody should check out. This guy's basically basically done what we're doing. Um, I won't. Just one sec. So, so this guy's got um, sort of like he's developing this still, right? So he's got his. Looks like he's got a single Arduino Nano. He's got 8 channels, which is what we're doing. Um, with the sliders, which is what we're doing. He's got 8 outputs. I'm not sure how he's achieving that. I'm curious if he's doing something similar to the SP 1200. Um, but this is big. I mean, this is like a really good uh, representation of what can be done, right? Looks like he's got some sort of he's got a stereo out, or looks like stereo out. He's got a high pass, looks like high pass out, maybe. Um, line in. So it looks like possibly a stereo line in jack here. Looks like what it could be. Um, yeah, I don't know if I can get like a copyright strike if I play stuff from this, so I'm kind of hesitant to play anything. But yeah, look, he's got like eight outs, powered by USB, 5-pin DIN in. I mean, like he's got basically what we're trying to build, right? Essentially. And he's kind of taken the same idea where he's taken all those buttons and stuff and then navigation stuff and he's whittled it down to a single rotary encoder and um yeah. Um So it's interesting, eh? It's pretty neat. But yeah, this is basically what we're doing. So it's kind of nice to know. Like, I wonder what else is under the hood. It looks like there's like could possibly be another board underneath with these standoffs. This style standoff, he might have like another layer underneath, like another board underneath handling other stuff. Because I don't know how else he would get all this stuff with just the Nano. Um, yeah, and he doesn't have any documentation as far as I can tell. Um, let's see if he. So that's just the. Is this the multi-channel one? No, this isn't the multi-channel one. This is one. But again, he's using a Nano. So that's not the multi-channel. Maybe he's got something on his website. Just curious if he has any documentation in terms of like how he did it. Yeah, it doesn't look like. Yeah, doesn't look like he does. He's got this really neat cassette deck though. You can get. This guy's got really cool projects. I haven't seen docs for it. Yeah, I wonder too. Brian, I wish there was some documentation, obviously, but I mean, he's obviously selling these or selling them as either like a kit or um, uh, input is only line in. Outputs are 8-channel individual output mixed out and headphone out. Oh, that's what HP is. That's HP is headphone out. Got it. Okay. Got it. Are the ISD 1720 SY chips gone? What's What's ISD 1720? Luckily, we're on the internet. We're going to find out what that means because I don't know. ISD chip quarter 7 ISD 1700. Okay. Is a high quality, fully integrated single chip multi message voice, record, and playback device, ideally suited for a variety of electronic systems. The message duration is user selectable and ranges from 26 seconds to 120 seconds, depending on a specific device. The sampling frequency of each device can also be adjusted from 4 kilohertz to, yeah, apparently, 4K to 12K. with an external resistor, giving the user greater flexibility in duration. It's an SPI device. Is designed for operation in either standalone or microcontroller SPI mode. The device incorporates a proprietary message management system that allows the chip to self-manage address locations for multiple messages. This unique feature provides sophisticated messaging flexibility in a simple push-button environment. The devices include an on-chip oscillator with external resistor control, microphone preamplifier with automatic gain control, an auxiliary analog input, anti-aliasing filter, multi-level storage array, smooth filtering, volume control, pulse width modulation, Class D speaker driver, and current/voltage output. Clever, clever. Well, isn't that something? Look at that. I don't know if you guys can see that block diagram. This block diagram. It's kind of hard to read. I wonder if I can rotate it so y'all can see it. I don't think I can. But there's all this mic, analog in, clock signal. And then I want to know about this. And there's like a dedicated pin for record, play, erase, forward, reset, volume. Okay. So interesting. I'd never heard of these before. Are these like, are these like, do they make these anymore? Like, here's an Amazon link. Some eBay. Here's DigiKey. Why is it going in French? English. Thank you. $9.75. Oh, there's a whole voice and record playback section on DigiKey. Huh. I had no idea these. I did. I'm, yeah, I'm new. I'm new to this stuff. I'm new to these style chips. So, yeah, like as I've said in the past, like here's 10 seconds. 10 seconds. Of course, none of them are in stock. I was just curious if there was like a. So there's all these different. Oh, okay, so there's ones that are listed in stock, but they're discontinued at DigiKey, which is fine. But here's like 2 minutes, 120 seconds, all different lengths. See, the ones that are in this different package are a little bit more expensive. I guess probably because I don't know. I don't know why they would be more expensive. Last time buy. Okay, so this is the same series. Same series as what this individual is using. So this guy here, he sounds like he's using these chips because he says, "Are the ISD 1720 SY chips gone?" Still the same chip in it. So I'm guessing that means that he's using that in this build, I'm guessing. Does he have any I would assume you need one chip for each audio channel. Oh, so we're still in that kind of like territory, eh? Of going with multiple chips, probably. I've never used anything like this before at all, so I'm new to this. I, honest to God, like I had no idea that these even existed. It makes sense that somebody would make a chip like this. That's the chip he used in the first one, so I take it he uses it for the Max version. Yeah, it sounds like it. It sounds based on the comment on his in that video. But I'm kind of curious what because like I think what Brian's saying is that I wonder he's using if he's using a single chip for each channel or if it's so Ed, you're saying that he uses 8 in the first the like light version, like his first version. Okay, so he uses 8 of them, eh? Wow. Okay. He uses 8. Yeah, that's crazy. So what would be I mean, what would be the advantage of these chips over I guess because they actually store the audio? Is that the I guess that's the advantage? I didn't know there was a Hackster page. Okay. I'll have to check. I'll look into that for sure. Um but I guess I'm guessing that'd be my only guess is that that's how he gets around how he gets around the memory part of it. Because there's no, from what I can tell, there's no SD card on here, right? Let me find. Oh yeah, you can't paste into the thing, right? What is it? Snap. I'll call it. Oh, let's just do a quick search. Snapbeat Hackster. Oh, here we go. Let's see if we can get the. So there he's got that. So here's his bill of materials. Yeah, so he's got no external storage. Yeah, right. Right. So he doesn't have he's so we're doing something different, right? Like we're going to be we want SD cards, right? Because we want to be able to save stuff and like pull it back up and be able to work on it, right? So ours will be different. Ours will be different, right? Um, just looking at the bill of materials that he's got going here. Okay. Well, that's kind of neat to know. Um, are there ones that just are there I wonder if there's versions of these. Just trying to think. I'm just trying to think. Um, like I wonder. Hmm. Let me think about that. I'm just wondering if there's any part of this that makes sense. I'm gonna have to dig into it a deeper. Um, See, I wonder if what he's doing is he's got his sampler input, right? He's got a sampler input, and then he's got eight of these basically voice chips, right? So I wonder if he's able to do it so that you record into kind of like one master chip, and then you distribute like the chops to the other chips somehow. Um, it'd be really I've never used anything like this, so I'm just thinking out loud here because these are cheap. $2.90. Let's just see what this one is. A three-channel digital chip recorder providing single chip storage and playback of high quality audio. Huh. This family uses flash memory to provide non-volatile audio playback with duration up to 64 seconds. Oh, but that's the thing. Based on 8 kilohertz 4-bit, which is pretty low, which is way lower than. Oh, wait a second. Sampling frequencies available: 4, 5.3, 6.4, 8, 12.8, 1632. Um, it looks like the max is 8-bit. with this particular chip. Hmm. Interesting. Okay. Well, this is interesting. It's interesting. It's kind of neat to figure out and kind of see how other people are achieving what we're trying to achieve here. Maybe if we the one I played with gave you an external clock for the playback speed. Oh, okay. Okay. Neat. Um, I'm just kind of curious if. Anyway, um, it's kind of neat. Yeah, like I said, I've never really played with any of these, so um, this is new stuff to me. So there's ones that you can just, so the one that we were just looking at, you could just play audio on it. So I guess there are ones that do playback and recording. 1800 series chips that use multi-level storage that seem bucket brigade like Brian mentioned earlier. Right. Right. The only reason why I'm looking at these, why I'm genuinely interested in these is because um anything to cut down on the amount of parts, right? And try to do it as elegantly as possible to get those 8 channels. Um, ISD. Oh, okay. Thanks, gamer. Thank you. 1820. ISD 1820. 1820? How to use voice recorder in player. Record 8 to 20 seconds. So it's this little guy here. Oh, this is just like a little breakout board kind of thing. This is an Amazon link. Do they have let's just see. Record up to 20 seconds of audio. I mean, like, that's great, but I would like to know the specs on it because we would like to match, right? We would like to try to match the sample rate, yada, 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 yada. Uh, Maybe if we do ISD 20 datasheet. Oh, here we go. Here we go. Single chip, single message, voice record playback. Yeah. Let's see. Provides high quality single chip, single message record playback solution with user selectable durations of 6 to 16 seconds. The CMOS devices include an on-chip oscillator with external control, microphone preamplifier, automatic gain control, anti-aliasing filter, multi-level storage array, smooth filtering, and speaker amplifier. A minimum record playback subsystem can be configured with a microphone, a speaker, several passive components, two push buttons, and a power source. Recordings are stored in on-chip non-volatile memory cells, providing zero power message storage. Yeah, yeah. Uh, Voice and audio signals are stored directly into memory in their natural form, providing high quality, solid state voice reproduction. That's great. Good to know. So there's our block diagram of how it works. So you got your microphone, right? Goes in here, blah, blah, blah. Out you go. So I guess the other chip was configured for line input as well, right? The 1720. And we would like a line level input. I mean, I don't know. I really don't know. So, yeah. Hmm. I mean, I guess the nice thing about chips like this is that it takes care of the memory part, but I don't know how I wouldn't even know where to begin in terms of being able to save, right? Um, like save it for being able to save like an entire project or an entire song or an entire beat or whatever to like an SD card with something like this. I would have no idea. No idea at all. So, but yeah, it's nice to be able to like look at this and see what they see what they do. It's neat for sure. Cool. Well, I think this was productive. Very productive. You can't save it. Right. Yeah, yeah. That's it. Non-volatile, right? They're gone. Like, and I wouldn't even, yeah, it'd be gone, right? Still need to see how people are achieving that. Anyways, this is what I'm thinking. I think I need to do more fiddling. Um, I need to get sort of, you know, I need to take a look at basically what Brian has set up now. So I need to, I'm going to order some stuff. I'm going to order an S3 for right now, start fiddling around, and then order that Adafruit module and start messing around with that and see if there's anything, see if I can get my head around how we're going to do the 8 channel output. Um, because I think Brian's got a little bit of an advantage in that regard right now because he's actually got all the hardware that we'll likely be using. So I'm going to order some stuff and get kind of caught up, and then hopefully next week we can chat about what to do. Have another chat about what to do and see what the best approach is going to be for this. Um, yeah, yeah, because I'm still not sure. Look at a PCM 1808. Got it. So I'm getting PCM. I'm gonna write that down. Uh, PCM 1808. You got a little breakout, little guy here. Yep. Cool. Yeah. So I'll check out one of those guys. Check out, um, yeah, check out that. I'm gonna get an S3, because this is not an S3. And yeah, so we'll do that. Okay. And I'll take a look at that and see if we need to do what just dig a little deeper so I get a better get my head around the hardware that we're going to be using. But I think this is the right way to go. You know, the more I think about it, is going this kind of route with these sort of modules and stuff. It's just going to make our lives a lot easier. It's going to be, cut down on the amount of other stuff. So, anyways, um, thank you for another productive discussion, guys. I really appreciate it. It's great to be able to talk about this project and get some other input on how to get this thing done, how to get this instrument built so we can make some beats. One other thing that I wanted to float around too while I'm kind of thinking about all this, and you guys let me know if you like the idea or not. Um, but and I know it's very premature, um, but as we're kind of building this sampler and completing the sampler, I was thinking of a way, or I was thinking of something that I thought would be a really fun idea to try to do if enough of us build the sampler. And that was that I think it would be really cool if we assembled like a compilation of songs and like beats and stuff that we all make using the sampler. Um, so yeah, just put it out there. See what you guys think. I think it would be a really cool idea. Um, yeah, let it stew for a bit. Brain stew. Brain stew. Anyway, uh, I gotta go because I gotta go spend some quality time with my oldest daughter and get her off her tablet. So anyway, um, nice. Good to hear. Good to hear. Yeah, I think it would be a really cool idea. Especially if we had, enough people doing this. I think it would just be a really cool way to cap off the project. Um, you know, maybe, if the stars lined up correctly, we could, press up like a limited run of vinyl. I think would be really cool. I think it'd be really cool. Be really cool. Anyway, I gotta go. So, hope you guys have a great rest of your week. I'll be making some beats with the ESP32 sampler on Saturday night with Ableton Live. Um, so if you're bored and you want to hear some crunchy sampling stuff, come on out, hang out. It'll be fun. I'm just going to be throwing ideas at the wall still. You know what I mean? So, anyways, thanks a lot for everybody who came out. Hope everybody, as I said, hope everybody has a great rest of their week. And I will keep everybody updated in terms of what I discover after I order the parts that I need. Okay? So, anyways, hope everybody takes care. All right. Take it easy, everyone. Thanks.